This elementary property of group tells us about the uniqueness of an identity element. Now, for any group G under binary operation star, and it's already identified as a group, there is only one element E in G, such that it satisfies this condition. We have here E star X equal to X star E equal to X for all X in G. Take out the term for all. There's only one identity element that works for all the elements in G. So we're going to show here that there is only one element. Okay? There can never be two. So what we need to do here, actually for this, there are a lot of proof for this, but let us use this one here. We are going to assume, okay, two identity elements. So we have E sub 1 and E sub 2. Both identity elements where E sub 1 and E sub 2 element of G. Okay? So we're going to assume that there are two of them. Okay? Because once we could show that these two are just the same, and that would mean it follows that there's only one element, identity element in G. That's our goal here. Okay? So once we assume into this, okay, I don't know if my wordings would be appropriate, but let me use it. For E sub 1, our first identity element, we can establish that E sub 1 star X is equal to X. Okay? Because, just like this one, this statement here, E star X is equal to X. And since E sub 1 is assumed to be the first identity element, then therefore, this is true. Okay? Then, of course, for our E sub 2, the assumption that there is another identity element following the same, we can also say that E sub 2 star X is also equal to X following this first statement alone. You will be using this later. Just for this portion, we'll have this part here. So both of this satisfied the idea that they are equal to X because we assume that they are both identity element. Now, since they are both equal to X, then by transitive property, we can say that E sub 1 star X is just equal to E sub 2 star X because they are both equal to the same value, same element X. So we can have this one here. Okay. Now from here, we can now use here by the left cancellation law. Okay, as one of the elementary properties of groups tells us that I mean not left, sorry, pardon for this, I'm not going to use left. Okay, I'm going to use here right. By right cancellation law, it's because we have X here on the right portion as well as here. The right cancellation law tells us that if we have the same elements here, we can simply cancel that and further say that E sub 1 is just equal to E sub 2. This is the proof that even if we have assumed that there are two of them, okay, E sub 1 and E sub 2, where they are both identity elements of group G under the operation star, and we have this following statements, it still boils down that they are just equal to each other by the right cancellation law. Pardon for this, it's not left but right cancellation law. So we have shown this already. But we have another statement for our identity here which stated this manner as well. So let's use the same, okay, this idea here, copying that, okay. So let's assume that we have not reached this portion. So for E sub 1, using the second statement here, we can say that X star E sub 1 is equal to X as this equality here. So the other one, for E sub 2, because we have assumed that it's another identity, so we have here X star E sub 2 also equal to X, as they are both identity elements on our group G that we have assumed. Okay. Now from here, similar thing earlier, we have equality. They are both equal to X. So by transitive property, we can say that X star E sub 1, this left hand side, is equal to the left hand side of the other situation as well. Okay. So by transitive property. So now, this is the time that we are going to use your left cancellation law. We have already shown this elementary property of group, the cancellation, the right and the left cancellation laws. You might want to review those videos. It states that we have the same elements on our left, this x here and x on both sides of the equation. We just simply cancel them, leaving e sub 1 equal to e sub 2. So similar as earlier, we have established that even if we have assumed that there are two of them, they are just the same element. This shows the proof of this theorem, which tells us that there is only one element, E, generally in our group G, such that it follows this condition. And that means our identity element for every group is unique and there's only one of them. This is again properties, laws, and theorems. Please subscribe now.